Hello, everybody. Hi, my name is Ryan Michella. I'm from Salesforce, and I'm going to be presenting today on gRPC in Go, C#, and Java. Call this a microservices code kata. We're going to implement the same service 3 different ways and demonstrate how we can make 3 different programming languages consistently and easily interoperate with each other using the gRPC framework. Who here is familiar with gRPC or has used it before? All right, cool. Some people have an idea. Cool. No one needs to know what gRPC is. I'm going to show you what gRPC is, and I'm going to show you how it works, taking you from the top all the way down, from specifying your service down to implementing your service in C#, Golang, and Java. So rather than creating a whole bunch of slides, let's just do this for real. All right. So let's briefly start with gRPC, what it is and why I think you should use it. So gRPC is, as they call themselves, a modern open source high performance RPC framework. For familiar with RPC, it's kind of the yin and yang of REST. REST is resource oriented, RPC is operation oriented. And gRPC makes it really easy to build RPC services. Cool things that I like about gRPC is it is polyglot. The gRPC framework works effectively with multiple programming languages, at least 10. It's a binary RPC protocol. So REST values maximum interoperability. So JSON over HTTP1, anything can speak that, everything from a Raspberry Pi to a supercomputer. gRPC instead focuses on performance and works really well behind the firewall. So it is binary serialization instead of textual serialization, and it's over HTTP2 instead of HTTP1. HTTP2 gets you a lot of really interesting features. So for example, it is a multiplexed RPC protocol. You can host multiple services on the same port, network port. You don't have to create like some binary RPC protocols. You have to open a separate port for each RPC you want to open. gRPC, you can run many services on a single port. Because it's built on HTTP2, you also get bidirectional streaming capability. So you can send unary messages, simple request response, but you can also send request, response, response, response. You can send a continuous stream of requests, a continuous stream of responses, and you can do this on all different kinds of platforms, including mobile, the browser, and the behind the firewall service to service. gRPC has a great open source ecosystem. There are lots of different companies and lots of different open source projects built around gRPC to make it easier to use. Has strong built-in security with native support for mutual TLS. And then finally has first-class observability built in. So this means that traces and instrumentation are built into the gRPC framework from the very beginning. So you get distributed tracing, you get operational instrumentation, all these kinds of things that you expect from a modern RPC and modern microservices framework all come out of the box. The last thing I really love about gRPC is that it's got a well-defined separation of concerns. So interceptors, which is a common way of building platform level features, like I want to do custom auth or I want to do custom field validation or something like that. You can put that into a separate piece of code from your application code, keeping these two worlds of infrastructure code and application code cleanly separated. gRPC, I should make that bigger, also does work really well behind the firewall. Like that's where I've gotten the most benefit out of it. Two machines, perhaps running in the same Kubernetes cluster, talking to each other point to point. It's great. gRPC is also really well optimized for building mobile clients. gRPC compiles well for Android and iOS, and you can use it to communicate back to your servers. And finally, it does work from the browser. gRPC being built on HTTP2 works over the native web. However, web browsers do not implement the trailer protocol. So with gRPC, you have to use a technology called gRPC Web. It's kind of out of the scope, but it does work. So the basic workflow of what we're going to go over in 3 different languages, Java, Go, and C#, is we're going to start by building a gRPC service from scratch. We're going to I'll show you how to add your library dependencies, so what you need to actually get the thing to compile and generate code. Then we're going to write our service contract, generate client and server stubs, implement the service itself, and then call the service. And finally, we'll end by actually doing a little round robin demo to show that Java can call Go, Go can call C#, and C# can call Java just as easily as they can call themselves. All right, let me just get checked out. All right. So this is actually going to be, let's do this with code. Can everyone easily see what's on the screen? Wonderful. So the first thing we're going to look at is, actually, check out. Gotta love how live coding works. 02. All right, so let's look at our Java program. Using Visual Studio Code here. And there it is, our proto directory. So this is the service we're going to be implementing. It's a very simple hello world service. What we do is request a name, and we return with a stream of a collection of responses. Very simple hello world. So protocol buffers splits the world, is a way of modeling operations and data structures in a programming language agnostic way. So as you can see here, we've got our little greeter service. It has one operation called say hello that takes a hello request and returns a hello response. Our data structures here are modeled using platform-agnostic types, but it does give structured messages. So we have hello request and hello response. And what's interesting is our hello response is of type repeated. So this means we're going to return an array. A neat thing about gRPC and its different languages that it works with is that the code generators generate idiomatic stubs for each of the different programming languages. So you'll see, I'll show with the repeated, we get idiomatic collections for each of the different languages, for Java, for Go, and C#. So we've got ourselves our little proto file here. And then let's take a look at our POM. So in Java, our POM XML is what explains all the different dependencies. So what we have to do is we have to set up our gRPC dependencies. And we get these just by going to, grpc.io is where you start. And grpc.io, all I did was go to Get Started and check out the tutorials section for each of the different languages that are supported over here. Went to the Java one and pulled the dependencies down. You set up your Maven dependencies. So we pull down protobuf. And then down here, we actually set up the code generator. So gRPC has a code generator for each of the programming languages it supports that generates your client and server stubs. So I just followed the online guide that says you copy this code into your pom.xml and Maven will generate the code. So what it does is it grabs the contents of our greeter file and it generates code off that. And if I do here, mvn generate sources, there you go, it starts generating, and you can see that it actually puts stuff in our target directory, gRPC Java and Java. This is generated code. It looks like what you'd expect from generated code. It's not pretty, but it works, and you generally don't ever have to look at it. All right, so now let's implement our service. Java greeter. All right, so we come to our little program here, main. And the first thing we're going to do is implement the service itself. And this is very simple. This is the server side. So we're going to create our little Java class that extends the greeter impl base. This is the generated code. If you dig into that, it gets, it's generated Java. But what we do is we override our say hello method. And so we're going to receive our request and a stream observer that we're going to put our responses on. And so when we get our request, we're going to say, hello, aloha, and howdy. So this is the protobuf way in Java of sending back multiple messages. It uses the builder pattern. And then we go ahead and on complete, we send it away. All right. Next thing we're going to do is we're going to go ahead and start the server. gRPC server is pretty easy to work with in Java. So we create ourselves a server builder. We say it's for port 9000, add a service instance, build and start. With that line, we have this service that we implemented using structured types. It's able to open a port, start listening, and accept gRPC traffic. And then we just await termination for the service. Thank you. That is the joy of live coding. Raise your hand if you've ever coded live in front of a studio audience. All right, mine is not up. All right, here we go. So now we're actually going to call our service. So we set up our server builder. Now we're actually going to call it. So we create ourselves, in the Java side, we create ourselves a channel. We say we're going to call localhost port 9000. So we're calling into our service. Notice I'm actually telling it use plain text. Out of the box, gRPC wants to use mutual TLS. So it's secure by default. You actually tell it not to be secure. So we'll go ahead and build our client. We'll create a stub around it. And now we're getting this nice, strongly typed greeter blocking stub. It has blocking stubs. It has async stubs. It has blocking and asynchronous stubs that you can work with. So you're not forced to do blocking code if you don't want to. We're going to go ahead and construct our message, our request message, which uses the same builder pattern here that we used for our response messages. And then we're just going to call stub.sayHello. And that is a strongly typed. You can see it's, if we dig into it, you can see it is a strongly typed message. It accepts a hello request and returns a hello response. That's pretty nice. We're not dealing with low-level, JSON object primitives and having to decompose hash maps of things. It's a strongly typed RPC from the beginning. And then, we call our service. We get back a message, and now you can see we're just doing for each over the response set. So we're getting idiomatic Java. We're getting back a Java collection. And then finally, we're still awaiting termination. And if I run this to just show it does in fact execute, we will compile it, build everything. And there you go. You see at the bottom, we started our service on port 9000. The server said service request from Java. And then we said, there's our responses. Hello, aloha, and howdy. All right, so that's Java. Now let's switch over and look at Go. All right, so Golang. Once again, we're starting with the exact same protobuf. This is one of the things that makes gRPC really powerful. You're using the same service specification for all the different programming languages you work with. This is kind of like if you're doing Swagger and OpenAPI, and you start with that OpenAPI YAML file. Same idea. It's an interface definition that you use everywhere. So we start with this, and then we actually have to, Golang is a little more tricky, but we're going to execute in here. I'm using a makefile to execute the gRPC generator for Go. So we tell it, generate over greeter.proto. We're going to provide the proto-c, the protoc argument of go out, and tell it to use the this here tells it to use the gRPC generator for Go. All right. Now let's look at our main. And there it is. OK. So gRPC for Go follows idiomatic Go patterns, which means we're going to, when we get our generated code, our greeter is an interface. So where would that be? That is, so greeter implements greeter, which is defined in our generated protocode. Once again, it is generated Golang. Greeter, it's somewhere around here. So you get these interfaces and structs that are generated for you. And so we are implementing the greeter interface on a struct that we create. So we've got our say hello message, and once again, this is the server side. We receive our hello request, and we return a response or an error back to the framework. So this is idiomatic Go code. It looks very different from the Java code we wrote, because Java and Go have different ways of thinking about the world. But we're achieving the same thing. We're returning, in this case, a Go structure with a message that is an array of the responses we want, and we return it back to the client. All right, so let's add our server. We're going to start up the server now. So we create ourselves a port, a net listen object. We're going to listen on port 9001 for this one. Create a new gRPC server and then register the greeter server. This is a function that comes, it's generated by the Protoc compiler. And so it uses this, there we go, there's the greeter server interface that was actually generated for us. We're going to register our service, and then we're going to create a Go func in the background that's going to listen on that port and actually start the server. So we're just going to create the server, and then we're just going to server.serve, tell it on the listener, and that's going to start up gRPC's listen loop that's going to listen on that port and start serving traffic. So going from a simple specification to implementing a fully running RPC server is like 30 lines of code. It's pretty awesome. Now let's call that service. All right, so we've added calling the service now. So on the client side, we're going to do this gRPC dial, telling it once again we're going to be insecure. We're not going to use mutual TLS. We're going to create a new greeter client, call the service. Here we go. We're constructing a hello request object that we're going to send to the service. Client.sayHello. This is strongly typed Golang. Get our response back and then iterate. In this case, we're just going to iterate over the response in order to print out its messages. And if we /run, this will execute, generate, there we go. And so we are now starting, executing, and then calling a gRPC service in Go using idiomatic Go, but it's all on the same basic proto. Last thing we're going to do is C#. And C#, this pattern should start looking familiar. So that's .NET dependencies. All right, so .NET does something, does it a little bit differently. So we start with our proto. There we go. Exact same proto we used for all the other services. But now in .NET, we're going to come into our CS proj file, and we're going to tell it, I want to create an item group here. This one explicitly tells the .NET toolchain to do the code generation when we build our project. Down here, we create an item group that says, add the greeter proto to our project. And so gRPC is fully integrated into the .NET Core, in this case, but .NET toolchain. So we can do the same kind of code generation you would expect in Java or Go. So let's implement our server. There we go. Program CS. All right. Same idea. We're building ourselves a server. We're building on top of our greeter generated code. Greeter base generated C# code. So we're going to get idiomatic C#. So in this case, we're going to return a task. It's actually going to build on C#'s native async capabilities. We're going to return a task, return our hello response. Once again, strongly typed APIs across all the different programming languages you want to work with. And then we're going to implement our gRPC server. Pretty straightforward. gRPC, we create a server object. We say we're going to bind a service. We're going to say, once again, it's insecure. Each platform has its own way of doing the gRPC client and server, but they're all native to the way that platform or that language expects it to be. We're going to go ahead and read and then just shut down the service when we're done. Setting up our client works basically the same way as it did in all the other programming languages. We create a channel on our port, tell it it's insecure, greeter.createClient. We've got our client, we call it, constructing a message, and then iterate over the responses. So 3 different programming languages, all using the same RPC. And if we run it, /run, there we go. All right, so we compiled and built, and now we're running, and you can see it's on C#. So let's do the last little thing, which would be, let's show all these 3 working, talking to each other. So cd Java. I realize this is small. I'll make this bigger in just a moment. Where did I leave off? All right, so let's do the round robin test. You've seen each language call itself. But now the real proof is that we can actually do /run on Java, run on C#, and run on Go. Oh, interesting. Oh, yeah, that's right. My Golang one is still running. There we go. Thank you. All right, so we have each one running. Now let's have Java call Go. And there you go. You saw Java called Go, and we get, service request from Java, and we get responses back to Java, but Go is what served it. If we call Go, Go called C#, C# called Go. 3 different programming languages, 3 different tool chains, 3 different idiomatic ways of implementing a microservice, but they're all seamlessly communicating using the same basic contract. Now, with other RPC technologies of the past, this didn't work. Like, they promised it, but it just didn't work. But gRPC actually does, and that's why it's such an amazing technology. So we've got 3 technologies all working together. That's what I wanted to show. Do we have any questions about how gRPC works or how it works across different platforms? Oh, microphone.
So how much additional work do you have to do to turn on mutual TLS?
Mutual TLS, it's pretty straightforward. You have to tell it which certificates to use. I guess you got to tell it the cert chain and the client and server certs. Assuming you've generated those and they're legit, it should just work out of the box. Question?
A long time ago, I had some experience with Thrift from Facebook. How do you compare this RPC and gRPC technology with Thrift?
My experience is that Thrift and gRPC basically fill the same niche. I feel gRPC is more mature at this point. So I've got the most experience with it. One thing that I really like about gRPC over Thrift is that at least out of the box, without using like Twitter's Thrift Mux extensions, Thrift is 1 RPC per port bound directly to a TCP port, whereas gRPC uses HTTP2 underneath as a transport. So it allows for multiplexing RPC, and you can have multiple services running on the same port.
The example was with strings, but more complex objects that are managed differently in each language.
Let me bring up protobuf. Actually, it's the Proto Developer Guide. Protobuf has full support for all different kinds of structured types. It has strings, integers, booleans, everything you'd expect, arrays. So it does arrays with repeated types. It also has well-known types like date times and some other package types, and I can bring that up. So Proto Developer. And yeah, you can find the language guide for Proto has all the different kinds of types it supports. Optional types, one-of types, where you can say, this field must be a cat or a dog. It can't be both. It's a very expressive way of creating your service contract, and it works equally well across all the different languages. Any other questions? Here. This repository is available online on my GitHub. It has all the code I demonstrated for this, as well as some good links to gRPC resources. Yes?
Do you have a use case when I should use a gRPC service over a RESTful service? I understand it's much faster.
It really depends on what your value is. So, if you're valuing absolutely maximum interoperability, anything needs to be able to call this service, REST is by far the lingua franca of, the open internet. It's simple JSON strings over HTTP1. Every platform has an HTTP1 client. Every platform has a REST client. Anything can talk to anything. The downside of REST is that you incur serialization, text to binary, binary to text. That gets expensive. There's also the potential issues of REST data types are not as strongly defined as gRPC and protobuf types are. So gRPC, I find, shines really amazingly behind the firewall, where you control both ends of the network. REST works really fantastically when you need maximum interoperability with anyone, anywhere on the internet, and you don't know who your caller is going to be.
So I know there's some things built into Proto for handling versioning and making sure fields are forward compatible and all that. Is there anything specifically that you've done in practice for versioning gRPC services?
So gRPC services are protobuf on the wire. So all of the protobuf backwards and forwards compatibility features are automatically supported by gRPC. Protobuf, generally things are not required, and so when a gRPC server accepts a message from an older client that doesn't know about new fields, those new fields just come through as null. If you're sending messages to us, you're sending messages with a newer version than the server understands, then that extra information is thrown away. So with a little bit of discipline, you can actually make microservices that are forward and backwards compatible, and allows you to make additive changes that don't break the wire protocol, which is a really neat feature.
Is gRPC in production mode right now, or is still in testing?
Oh, Cask of the microphone.
Sorry, yeah. Is gRPC protocol in production in big company right now, like Salesforce, or is still in some kind of beta stage?
Oh, gRPC is rock solid. It is in production mode at Salesforce. It's in production mode at hundreds of companies around the world, if not thousands. Google uses it extensively internally, and as I've heard, is actually migrating to replace their internal RPC with gRPC. And then lastly, gRPC is it's the communications protocol used inside of Kubernetes. So Kubernetes uses it, a bunch of other cloud native, Istio uses it, all sorts of other cloud native technologies are built on top of gRPC. So gRPC is rock solid right now.
How prevalent is HTTP 2 what needs to be implemented to get that protocol?
Sure. The gRPC server framework across all the different languages comes with an HTTP server built into it. So you don't have to use like some third-party HTTP server with gRPC. It's built to natively host services in their process. HTTP2 prevalence in general, intermediate proxies sometimes don't have the best HTTP2 support. Some of the cloud-native load balancers don't have the best HTTP2 support. gRPC, why I say it works best behind the firewall is because it really works great in like a service mesh type environment where you're doing point-to-point communication between servers, or you control all of the intermediate infrastructure, like you control your load balancers and you control your proxies. When you start getting into like random equipment on the internet that you have no control over, its HTTP2 support may or may not be there. All right, well, thank you all so much for coming out and learning about gRPC. If you've got any other questions, I'll be up here.